So, hello everybody. I guess good evening for the ones in Europe. Good afternoon for the people coming from the eastern side of America, and good morning for the people from the Pacific Coast. This is a presentation I was supposed to give at the UC last year, but could not because of last-minute issues. Peter gave it. It's a slightly revamped version, so let's go through. This is about the process to choose a high availability solution for MySQL. So about us, of course, I am a consultant at working for Percona. So you can find my latest blogs on MySQL performance blogs. Before that, I was an employee for Sun, and before that, MySQL. I have blogged quite a lot on BigDBA along with Matt Yankovic. So if you want to follow up there, it's possible. So here's the plan of the presentation. First, I will introduce some high availability terms so that we are all on the same page regarding the definitions of things we will talk about. Then I will introduce some questions that you need to ask yourself before setting up an HA solution. Of course, HA solution requires a specific mindset. I'll then discuss that. And finally, I'll present the most common solutions with regarding higher availability with MySQL. I will introduce each of them, the pros and cons, so you'll be better equipped to decide which solution is the best for you. So let's start with the definitions. First, of course, probably most important is the term high availability. The acronym is HA. It's basically a computer architecture design and implementation that is targeted to improve the availability of a given service. There are many types, but that's basically something that is designed on purpose for high availability. That is more than a single computer alone. We will also often talk about uptime and downtime. That's when the service, uptime is when the service is on, running normally, and downtime is when you have service down for for not desired time, so that it was not scheduled to be down. The level of availability is typically the fraction of time that you are uptime compared to the time you are downtime. Normally, you count the level of availability in terms of the number of nines. 2 nines would be 99%. 3 nines would be 99.9, and so forth. So the highest number of nines that you get, the better the availability is. At 4 or 5 nines, we're talking about just a few minutes per year of downtime, so it's fairly low. High availability setups are designed in a way that they reduce single point of failure. A single point of failure is something that if it's down, the whole service is down. It can be many things. If, let's say, you have a cluster, very expensive cluster that share the same switch or the same UPS, then those devices are a single point of failure. if the switch goes down, the whole cluster goes down. So you need to think about every aspect of the setup that you are building and isolate those single point of failure spots and try to rework the architecture so that you can survive the loss of the device. So in order to remove the spot. Once you had a failure, you will have recovery or a failover. This is the process by which the HA architecture will survive the failure, will recover the failure. And we will also talk about fencing and stone. It's basically a way with an HA architecture, you can have computers that are stuck and not responsive, and that hold resources that prevent the failover. So at that point, you need a means for the surviving nodes to be able to remove the failed node from the cluster. This is what fencing and StoneNet, which is a mean of fencing, is for. So it can be very simple. Now, nearly every computers have, every servers, I should say, have either IPMI or IO or something similar. Those are good StoneNet devices. I do prefer IO. The interface is more user than IPMI, but both works. So basically, you can shut down a computer from another computer. And then the last definition is cluster. Taken at a very broad range, a very broad definition, sorry. A cluster is just a group of computers that act together for something, for a service, or a cluster can be oriented toward performance or toward high availability, or in some cases for both. NDB cluster is the kind that we could say it's for both. So now that we have defined some of our definitions, let's introduce the questions you need to ask yourself before starting. The first one is probably the most important. Do you need HA? A way to rephrase that is, what is your downtime cost? If the service is not used at night and it's down during the whole night and the cost is nothing, then you probably don't need something that will react automatically. Even if, but maybe during the day it's very active and it's critical, and there's not always someone monitoring it. So there's a lot of things there. But if your downtime cost is very low, think twice before investing into an HA solution. Also, when we talk about downtime cost, it's not only the money. If you have a high-profile website that is down for many hours, there's cost of transaction probably, but there's also a cost in terms of corporate image. It sends a very bad, it's bad for the reputation not to be able to have a site that is up and running. People might distrust your service altogether if something as visible as the website is down. Next, and related to what is your downtime cost is, in terms of cost, what would be acceptable, let's say over a period of 1 year, that could help you also figure out how much you want to invest to get a return on your investment in a reasonable amount of time. So if over a year, you can accept easily $5,000 of downtime cost. Then you can gauge how much you want, and considering your downtime cost, you can gauge how much time that represents and choose your solution accordingly. Also, if you have windows of time, let's say between 3 a.m. and 5 p.m. where the service is not used at all, that offers opportunities for maintenance, and that could reduce the downtime cost associated with the solution. So that's another thing to take into account. And finally, probably the most important, since I'm guessing most of the ones that are attending right now are technical people, we tend to create something that is cute and that is a challenge to install and develop. But we need to make sure we're not over-engineering the problem. A solution that is unnecessarily complex is not necessarily good. Complexity has its cost and can lead to problems if it's not handled correctly. The second question that will be used to sort out the various solutions is, can you afford to lose some data? There are solutions that rely on replication of data, and up to very recently only asynchronous replication was available, and that can lead to problems. If you cannot afford to lose a single transaction, that could lead to problems. But in many, many cases, it's fine to lose, let's say, a second worth of work or a few seconds. And for those cases where you can afford to lose some data, then many more options are available. A more specific question is, are you relying on some MySQL features? By MySQL, I mean full text indexes and GIS. For full text indexes, there's always a way to use either syncs or loosing, depending if you are PHP or Java shop, basically. But for GIS, there's no real solution except using another database, since MySQL supports. MySQL is the only storage engine to support GIS. Another related question is, what is the write load that you are expecting? I can rephrase that a bit, like to say how many threads will be writing simultaneously. If you have many, many threads, it might mean that you will, for example, overflow the replication thread in MySQL. So the write load will be the problem. That's a fairly common problem. People on average will have a decent write load, but they will have huge spikes that last for anywhere from a few minutes to a few hours, and those spikes will remove the option of using a simple solution based on replication. You can also use your spike in ops per second for writes to get about the same figures. Also, what will be the size of your data set? If it's fairly static, will it be fairly static, or will it grow to 10, hundreds of gigabytes or terabytes? So that's another question that can help narrow down which solution is the best. Of course, the HA setup will need to be maintained by someone. So if you have an IT department that is not familiar with those solutions, or your support company is not familiar with them, it might cause some problem. So you might need to choose according to what you can support. It's useless to have a very complex solution that when it fails or when it needs maintenance, no one knows how to do it. And finally, one of the most important also that that is related to the first one, what is the downtime cost? No, the second one, sorry, is how much you are ready to invest. If you have a very limited budget, then you will have to limit yourself to the most simple solutions. But if your budget is more substantial, then we might explore the most complex solutions. So now let's go to the HA mindset. So high availability is not only about technologies. That may seem very basic, but people tend to rely too much on the technology. No technology is a complete foolproof. Even if you have the best solution, if somebody do something crazy, it will behave in a crazy way. You can have a very HA database, but if someone issue a drop database, it will drop the database in a HA way. So the data will be effectively down. So very good operating procedures are required. An HA shop that is serious about HA should have a testing environment for the code base and a staging where they can test the code with some load on it to see if there's a new queries that behave and that takes too much load or performs badly, so that they can be identified before being pushed to production and cause a downtime that is not related to the cluster, but is related to a new feature or new behavior of the application. Of course, an HA solution that is not monitored and that there's not a proper alerting infrastructure will behave bad, will be in danger. I've seen it, and many others have seen it too. If someone is, I've been on site for companies, and you go there and you realize in front of them that, hey, your array is degraded for the last 6 months. So it's something that you need to check the servers and be aware of their health. Also, HA is not an isolated thing. You need to look at a broader. You need a broad view of your infrastructure. Let's say you have a web service that somebody is telling you we need 5.9 availability for the web service, but then you look at the ISP contract and the availability is 3.9. It's totally useless to go higher than the ISP availability. Normally, in data center, the power is usually okay. It's not the most common failure. You have UPSs, you have generators, so it's normally not that it will fail the first. But recently, over the last 2 years, I've seen 2 or 3 cases where the cooling went down. So the whole data center had shut down because it was overheating. So there's a lot of aspects there that not only the computers need to be HA, but the power, the cooling. And for very high HA requirements, you might need very extreme measures. I've seen one site that was in a very strong need of availability, and they had two internet access on different streets. The building was at an intersection of two streets, and they are to be connected from those streets because it happened to them that a truck hit a pole and cut their internet access from one side. So they required those separate access. So now that we have reviewed the terms, the questions, and the mindset, we're now ready to look at the various solutions. The most common and by far, which works very well for many cases, it's a good solution. It's replication. It's very simple. You can set it up in a matter of, in 1 hour it should be running easily. It's simple to manage, simple to monitor. At its simplest expression, failover is manual. You need to repoint the application to the surviving node. So what happens when there's a failure is the following. So the master dies, replication is no longer working, but the slave is up to date. So you promote the slave to rewrite. So you point the application rights to the slave. So this allows for rights to continue. When the master will come back online, you will need to resync. But the application has been down for only the time of switching the application from one server to the other, which should be very decent in terms of time. We're not talking about many hours. We're talking about a few minutes to change, to realize the server is down and to change the config files. A bit more complex, just still based on replication, is to use a manager. So a very common manager is MMM. So MMM monitors the replication and allocate VIPs around the servers for read and write. So if you have a master setup, one of the masters only for read, the only one has read and writes, and if it fails, then we have the following solution, the following situation. The active master is down, so MMM will realize that and will transfer the virtual IPs to the surviving master. So the surviving master will have two virtual IPs for read and the virtual IP for writes. Of course, I've not drawn here, but you can have multiple slaves attached to these masters. And MMM will manage to reconnect the slaves to the correct master. There are also other solutions that can be used with replication. One that we hear quite often is Tungsten. It's a kind of proxy layer that plays into the replication stream. It has the intelligence to know what's going on at that point of view and controls how the application connects remotely. It's fairly good. It's good for something. It does not require VIPs because it knows where to connect from the Java layer. So it's interesting for a situation like on EC2 where you cannot have VIPs. So that's something fairly good. There's been some talk with Limbit. They have developed a way to manage replication with pacemaker and heartbeat. It's very cute, but right now it needs some little, there's some small features that are still needed that once they are there, it would be awesome. If a slave lags too much, there's no way in pacemaker to just disable it for some time. It's either a resource is on or off, and if you fence a slave that is lagging because the resource is failing, it's not really good because it will not recover easily if you fence it. So it would be nice to have such a feature with Heartbeat, but with pacemakers, sorry, but it's not there yet. But it's quite close. I would really like to see a pacemaker-based solution that can compete with a solution like MMM, because pacemaker has much more intelligence of what the other nodes are doing. It's a more polished implementation. MMM is fairly limited on a few things, can easily jam and be stuck. Although it works nice most of the time, there are those few times that it does not react like it was supposed to or expected to. So the next thing, what are the pros of replication-based solutions? The most important, I guess, is it's very simple and it's cheap. It's inexpensive. So it's something that at least if you have 2 servers, you could implement in a matter of a few hours, and it will work fine. Also, if you rely on MyISAM only features, it supports MyISAM, so it works very nicely with it. Another very interesting feature, all the servers are active. There's no idle standby. We'll see later solutions where you basically have hardware that is doing nothing. It is very good also to scale the read operations. It's probably one of the big things with the MySQL success is the way you can scale out reads for web application type of load with replication. So I'm surely not, you are not learning that MySQL is good at that here. I hope so. Another good thing, since all the servers are active, their caches are warm. So you don't have a performance penalty to fail over like you can have with other solutions. Also, finally, and it's very important, this thing, you can do online schema changes. If you have a master-master pair, you can alter the schema on the passive one, fail over, and alter on the other one after. And you are always online. If you want a receipt to see how to do this, if I remember well, Artemis on the MySQL Performance doc did a very detailed step-by-step procedures for doing online schema changes. Also, something that is not there, the slave can be used for backups, for reporting. So there's a lot of added values to have a slave. But of course, if replication has a lot of pros, it has some cons too. And probably the most important is the availability. If you're doing manual failover, it will not fail over very rapidly. We'll have to do it manually. With a solution like using MMM, it will be better in terms of time. But remember that replication can break, and probably not. It's not something new for most of you, I guess. You probably have already repaired a slave that is locked on some statement that caused an error. Most important, replication can lag behind. If you want to fail over to a slave that is, let's say, 1 hour behind the master, you have to wait. You cannot send writes, when it's not done writing what has sent to the other one, it have inconsistencies. So that's probably something very important. Of course, replication can also be out of sync. It's very easy to have two databases that are not the same. That's why there are tools like mktable checksum and mktable sync. Those are popular because that happens, and happens quite frequently. So I already talked about the manual or semi-automatic failover with MMM. Also, replication is single-threaded, so that limits quite drastically the write performance. In most cases, if you don't write too much, it's fine. But for write-heavy environments, it's a no-go. A single-threaded slave will lag too much. It goes back to replication can lag behind. Of course, also replication is async. Transaction can have been written to the master bin log, and the master can have crashed before the slave have the statement, and it's really a lot. So you can lose some data. This is much improved with the semi-sync replication of 5.5. So it might be a con that will be at least partially removed, because it's much better when you know that one of the slaves has the data. Most solutions have no fencing, although MMM can do it, but I've had mixed results with it. So some edge cases are not always handled. Demananda and I have worked a bit on the MMM code base to correct some of the lockups that could happen. We hope they will be integrated soon into the main branch. But we have discovered a few situations where basically MMM will not correctly behave if the node is reachable, but the remote agent cannot perform its task due to, let's say, a file system failure. So in those cases, it will hang there forever. So it's not very good for that. The next most common solution is one that uses shared storage. Shared storage can either be a SAN or, as we will see later, DRBD, which is a kind of SAN emulator. Basically, for those type of setups, you need a cluster manager. Heartbeat has been a very popular cluster manager for MySQL. Now I tend to prefer using Pacemaker. Pacemaker is a bit more complex, but is much more flexible. But Heartbeat still works. It's doing fine. You can use Red Hat cluster. You can use, there are many cluster manager that offers about the same type of features. Basically, what the cluster manager do is it manages a few resources: a virtual IP, a mount point, which will mount a shared partition on a SAN, and MySQL. What happens when there's a failure? The surviving node, the standby, will realize that the active is not responding to the beats and will initiate a failover. During the failover, if for whatever reason it cannot take over a resource, it will sense the other node. That's why fencing is very important. It will sense using, let's say, ILO, and request the other line to be shut down and restarted. Then it will mount the partition, start MySQL, and grab the zip. So at that point, MySQL will be running on the standby node. That means that the surviving node will have to run through storage engine recovery. So since MySQL does not support recovery in a sane way, in a predictable way, it limits our choices to engines that do support recovery. And right now, the most common that supports recovery is InnoDB, although there's no reason that other engines will not work. I'm thinking about Maria and PBXT. So what are the other type of situation is with DRBD? It's illustrated here. It's about the same thing, except that instead of having a fan, which is a single point of failure, so you need a good SAN for any decent availability, you have only local disk that are mirrored through with the DRBD. In terms of availability, this is very elegant because there's nothing that is shared. So you have a master that writes to its local disk. Sorry. The local disk are all the writes are mirrored in real time to the standby node, to its disk. A commit will return only when it has been written to both servers. So that DRBD limits slightly the amount of writes, but it's very decent in terms of impact. So it does not affect too much the performance. What happens when there's a failure? It's about the same. The surviving node will take over the resource. Instead of mounting the SAN, it will make it DRBD partition primary and mount it, and then start MySQL on it and grab the zip to offer the service to the web application. So what are the main pros of the shared storage solutions? Normally, there are no data loss. If the DRBD is sane, if the SAN is sane, there is no loss of data. A transaction that has been committed is on disk and is on the other side will be recovered when after the failover. Of course, this does not take into account InnoDB flush log TRX commit equals 0. In that case, you could still lose 1 second. But if you are truly ACID using 1, it will work correctly. You have a much higher write capacity than with replication. You can write with multiple threads. So if you have write operations that are fairly complex, it will boost because you will be using many more cores to do it. So it's much better. The failover is fully automatic and reliable. If you use a decently sized InnoDB log file, I mean decently, I mean small, like 100 megabytes, the failover is about 1 minute. I've not tested with ExtraDB and 5.5 fast recovery, but I'm expecting that since recovery is much faster with those, that we could probably increase the size quite significantly of the log files and still have decent recovery time. So the failover time will be mostly controlled by the InnoDB log file. There's of course you need to take into account the beat ping, the number of failure required and things like that into the calculation of the failover time. But usually the largest contributor is recovery of InnoDB. Also, like I just mentioned, there's no single point of failure with DRBD. So very elegant in that perspective. I would say that if, at least for the low-end fans, a DRBD solution has higher availability than a SAN-based solution. So I'm not talking about very big SANs with multiple switches that are very expensive anyway. But for a small SAN or a DAS, the availability of DRBD is better. Of course, it also has some cons. Like I mentioned before, it only works with engine that supports recovery. That excludes MySQL basically. So with MySQL, if you require MySQL full text and MySQL GIS, you're a bit stuck with solutions supporting replication. But if you are using almost only InnoDB, or you have MySQL tables, but they are written very rarely. So let's say you batch update once per day, then the window of failure where you are vulnerable to a bad failover is very small. I would suggest it's okay to run with MySQL in those cases. But if you constantly write to MySQL tables, the risk is too high to be to have a shared storage solution using MySQL. Of course, it's also a solution compared to replication that is more complex. Most of the time, for performance and reliability, we will use neck bounding, we will use fencing. We need a storage manager that has that needs configuration, either heartbeat or pacemaker or whatever. So there are more moving parts that needs to be adjusted. So it's more complex in that perspective. It do require fencing. I've seen many setups and that are not using fencing. It will work most of the time, but you have to realize it's less HA than a solution with fencing because it can stuck. If, let's say, two servers are sharing a fan and one of the server is in user space oops, so the kernel is still running, but user space has crashed and it has mounted the SAN partition. How do you resolve that? You need fencing. If not, the standby will not able to take over the resource and do the failover process. Also, a server is standby. Its name is standby, so it's really idle hardware. You can use it, but you have to be very careful because if there's a failover, you need to be able to quickly stop the things that were running there and move in order to accept the HA resource. So most of the time, we recommend using a totally idle server. Probably one of the big drawback of doing a failover is that the caches, in this case, the most common cache is the InnoDB buffer pool, is cold after a failover. So if the server has a large buffer pool, let's say 100 gig, it will take hours to recover the right performance level. With XtraDB, that limitation is a bit removed with the LRU dump and restore. You can dump every few minutes the LRU, and upon startup, it will restore the buffer pool to approximately the same state. It's not perfect, it's not instantaneous, but the database will be available while this process is going, so it's not blocking. It will just speed up the the warm-up of the cache. And of course, since the data is shared, it's not possible to do online schema changes. So the last big solution that I will talk about is NDB cluster. It's a very different type of solution. It's a shared knotting architecture that has basically three types of nodes. You have the data nodes, the NDB nodes in pair into the kind of cloud. You have management nodes that are used as controlling device. They don't perform much work, so they can be co-hosted with other types, with the SQL nodes. And then you have MySQL servers that we call the SQL nodes that are basically proxies between the SQL and the NDB world. Everything within an NDB cluster can be removed without failure. Everything is redundant, so it's fairly elegant. If you look at a possible failure scenario, you could lose as much as, in that case, 1, 2, 3, 4, 5 servers. Even you could lose the last management node and you will still be up and running until you lose something else. So it's very resilient to failure. The performance will be degraded, of course, but it will still be up. That's fairly unique, and that's one of the big plus of NDB cluster. So the pros of NDB cluster is, as I know, it's about the only sharding framework really mature and that works nice. It's sharded. It's a sharding framework. Everything, if you think of sharding, it's there. It's a sharding framework that supports transactions, that is HA, of course, high performance, and has consistent backups. That's something that you, when you start sharding, that you don't necessarily think about, but to have a consistent point-in-time backup is something very valuable, and NDB cluster offers that. Like I said, there's no single point of failure, so the level of HA can be very good. It is scalable. You can add node groups, the pair of data nodes that you can add more now online without the application being down. It supports a very high write capacity. It's fairly unique. I've reached on many clusters easily more than 100,000 write operations per second. There's nothing else that can match it. If you need a very high write load, if you have a very extreme write load, NDB cluster is something you need to look at because it can do quite amazing things. I've done a queue processor, a very simple one, 2 data nodes, and it was able to handle, I reached 250,000 rows inserted per second. And it's not because I could not have pushed it more, it's because I was out of load files. So it's fairly impressive. And another feature that is not very well known, it supports HA replication. You can have multiple master and slaves, which is quite unique. It's not trivial to manage, but it's possible to have more than one replication channel. So if one is down, the other one will take over. So that's very nice. Another pro that I've not talked about, most maintenance operations like upgrades, configuration changes can be done without losing the cluster. They are done in what we call a rolling restart, which is very interesting. So when you're talking, yeah, you need maintenance to change version. With NDB, there's always a path to upgrade without stopping the cluster. But also, NDB clusters has a lot of cons. It's freakingly complex. Compared to the other solutions, it's something. the complexity of it is probably the biggest showstopper, because people will try, fail, it's too hard, because they will use default values or a setup that is not perfectly good, and they will fail, and it will give them a very bad experience. Also, it's not an as general solution as the other ones in terms of database. So most of the time you need to rework the schema and the queries to get a decent performance level. When the queries are very in line with what NDB can do, it can be very, very good. But for some other operations, like one that are using large joins, it can be more difficult. Of course, since it's more complex, the skill set required to maintain a cluster is usually higher. So you need a person with more experience at debugging and at maintaining hardware and software. You don't give the maintenance of an important NDB cluster to someone that is, let's say, more junior. And of course, most of the data in NDB cluster is in memory. It now supports disk-based tables, but all the columns that are part of an index will need to be in memory. So that puts a very high pressure on the memory footprint. And remember, the nodes are in pair, so you lose half of the memory that you have. So that will require a lot of hardware, a lot of memory if your data set is large. Same, of course, you need at least 3 physical servers for a HA setup, 2 data nodes, and 1 SQL node with the management node running on it. That's the minimum you can have for an HA solution. And 3, you still have only 1 SQL node. The data is still there, but nothing could access it. So in reality, it's probably more like 4 that you will need. 3 is the minimum for a working cluster. It is not trivial like working on your laptop. Of course, all those solutions I've given you are isolated. They can be mixed. So that offers you a lot of flexibility. Let's say you require geo-redundancy. You can have 2 shared storage clusters and 2 remote locations that are replicating to each other in the master-master relationship. Or NDB cluster with replication, same thing. If you want to scale the reads-ups, but you want a HA master, you can have a shared storage master with many read slaves. That will work perfectly well. Of course, if you are doing sharding, you could use a global database using a small NDB cluster, which is very fast and HA, and then the shards could be using a shared storage solution. So there are many, many options that you have. So that's about what I had to say today. Now, if you have questions, I'm available to answer. Probably the chat is the best solution. I see Tim is asking if the slides are available. Yes, I'll make them available. Wait a minute, I need to figure out. I did it the last time. I'll try to do it again here. Give me 2 seconds. No. Nikki is mentioning that The webinar has been recorded and will be online for people to review. So if I'm looking here, I don't want to close the session, so I'm not sure the way to do it. Select content to share. It's probably that shared document here. The slides. I do this thing here. I hope it will come up all right. It's a PDF document, so you should see the content available. Oh, that's not the thing you want. So I just hope that the file has been transferred correctly. So just tell me if it's not the case. It's tricky. Okay, I have a question here from Mikey. What are the advantages of shared storage for automatic failover versus a simple master slave setup? Why it is so tricky to have failover with replication? It's tricky because replication can lag, replication can be broken, so you need to take that into account. When you failover, if there are sessions connected to the master that you're failing away from, you will need to kill them. There's many operations that need to be done. And although it seems not that complex, it is much more than you can think. It's hard to script correctly. Wait a minute. I'm reading the next one. I don't know the DB shard solution, so I cannot answer the question from Chandler Washington. I will look at it for sure. If it's a reliable solution, it might be very interesting. Chris Weiss is mentioning it under shared storage pros. I mentioned that the write capacity was much higher. And he asked me, what is the bottleneck that has been removed? It's because with shared storage, you are writing using multiple threads, so more than one core. So if you have, so with replication is single threaded, so only one core is doing the SQL, so that's a very big bottleneck there. So with shared storage, you can write using all the cores that you have. So if the write capacity is much higher, CPU-wise, that way. What's the main problem with a crashing MySQL running MyIVAM? That's from last Cronus. MyIVAM is not crash safe. MyIVAM is very lazy to write to disk. To resume, it does not sync to disk. It only writes to the OS write buffer when it wants to. So that's something quite serious. I've seen many corruption issues with people having large tables. So you are writing, the data on disk is something. You might have missing rows, missing things. That's part of the problem, but it's not the main part. The main part are the key buffer. The size of the key buffer can be very large, and it's very lazily written to disk. So at some point, you can end up with many, many dirty pages, and if you crash, the index is completely corrupted. You can try a query that you know you have rows with, let's say, column B equal A, but it's not returning anything because the B tree on disk is broken, because only part of it has been written from before the crash. It's probably the most important problem is the syncing to disk of the index file, the MYI file. From Romain Guino, why does NDB only support read committed and not repeatable reads? It's basically because of the distributed nature of NDB cluster. In order to support repeatable reads, you need to be aware of which transaction number you are at. So since you can have multiple SQL nodes, transaction will be coming from everywhere. It's hard to get a consistent transaction number by the transaction. There will be a lot of packets on the network that will need to be exchanged just to maintain that. So it would be a very large, there would be a very large performance penalty of using something like, of implementing something like repeatable read. That's why NDB cluster only supports read committed. When it's committed, it's available. That's simple. So it's the data node that decide to make it available once it received the commit request for that part of data. Last question, do you have any experience using VMware or VMware HA to provide MySQL HA? It's about the, I'm guessing VMware HA will be using a shared storage to move the instance from one server to the other. So in some sense, it's quite similar to shared storage solution. Even then, even if it's using VMware, if MySQL crashes, MyVM will still be at risk because the information is lost. The information about the index file especially is lost. Although I have mixed experience with virtualization with MySQL, I know it works well, but the performance penalty can be significant. You just need to measure it compared to bare bone. It really depends a lot on the tuning, the type of solution that you have, but it can be significant. So there are not a lot of benchmarks on that because the companies behind those solutions are picky about publishing benchmarks. So if that's all the questions, I hope I have not forgotten any. Oh, there's another one here. No, okay, it's the same. I have answered, I think. I'll just review if I have not missed something. Is MySQL cluster designed for social gaming applications? It really depends the type of queries. I have done some social gaming type where you have many-to-many relationship between tables. It really depends the flexibility of the application. Also, MySQL has what we call a direct API that bypass MySQL. I've not talked a lot about it. except to mention that MySQL is a proxy between the two worlds, the SQL world and the NDB API world. But NDB API can be very fast and you can build queries in a way there that might be better for social gaming, although it's not perfect either. But you can use a lot of batches. The main problem with social gaming is the way MySQL runs the queries. It's nested loops. So if you need to read 1 million rows from table A that will query rows from table B, that will take time, because for each row of table A, you'll need to hop over the network to query table B. When data is in memory, we are talking about nanosecond of access time. Like if the data is in the InnoDB buffer pool, it's very fast. But when you have to hop over the network, the cost is 100 microseconds at best, except if you have very fast interconnect. But on a regular gigabit network, it's 100 microseconds. So for each row, that time will add up, so it might be quite long. Okay. Okay. Yes, okay, we're talking about, there's a question here from Chad Stovern that NDB cluster has improved joins a lot. Yes, recently, I'm not sure it's GA yet, but you can, NDB has now the feature you can push a join between two tables to the nodes. It improves in some circumstances in a drastic way. If all the data is local to a node, it's really magic. It's not yet as general as working on a normal database, but it's true that it improves a lot the performance of joins. A question: why can't online schema changes be made using shared storage? By online schema changes, it's not what is now possible with the InnoDB plugin to add an index online to a table. I'm talking about altering a table in a normal way. So with master slave, you basically don't use the slave while it's doing the outer table. Once the outer table is done, the slave will recover, and once it's in sync with the master, you switch the roles. That do work well with replication, but you cannot do that with shared storage, because you'll have to change the files that are shared, and during that change, the files are locked, are not accessible. You cannot use the table. I hope it answers the question. I have a question from Laurent Brechon-Cornery about using NDB cluster for internet payment solution. They are afraid of performance issues. Basically, if you are doing a lot of simple transactions with many queries that are using either simple joins or access by a primary key, NDB cluster will be very hard to beat. Will probably be the best solution in terms of write scalability and read scalability. But if you have very complex joins and OLAP type queries, then NDB is probably not a good fit. For OLAP type queries, what I suggest people is to have an InnoDB slave to the NDB cluster. it might lag behind, but you don't really care. What you want is that at some point in time you have a consistent database that you can query. It's possible to have a non-MDB slave to an MDB cluster. There are no issues with the InnoD plugin and HA. It works perfectly well. XtraDB, of course, is based on the InnoDB plugin. It works well also. I have an update on the question about the internet payment solution. Basically asking me if I think Heartbeat solution with a SAN would be better. It depends on the right load that you have. If you think you will have a sustained write load above 10-20K rows per second, be sure the data set fits in memory for the Heartbeat solution, and you will probably need a very large InnoD log file in order to work in a decent way. I suggest you look at XtraDB that can have more log file bigger than 4 gig to have a sustained write throughput of that range. But if the write load is, let's say, less than 5K, then shared storage is perfectly fine. Probably replication will be fine too, but since it's payments, you cannot lose data. So, but just be careful about the write capacity. If you don't know if it's bounded or not, then you have an issue with the shared storage. Okay, you mentioned my MMN pacemaker. There's also MMN MySQL proxy. Yes, I've worked a lot in the gaming industry, and MySQL proxy is not great there. For one reason, it's single-threaded. So if you have heavy queries, it will work correctly. If you have many small queries, it will be very quickly the bottleneck. So make sure you use it correctly. Probably you would need many MySQL proxy instances. I would recommend likely one replication servers that all connects to all the database. So if they are not, I hope I didn't forget any questions. Looks like it's okay. If it's all, we'll be able to end the presentation now. So thank you very much for your for having been so many to attend. I hope I have been able to answer a few of your questions and guide you toward the best HA solution for you. Okay, thank you very much.